Yes, hello, my name is Aiden. I'm here with my dog Bambi, and today we're going to be working on Speedy Spaceship. Speedy Spaceship is a game where you fly a spaceship and try not to die. It is primarily right now an iOS game, but we're hoping to release it on iPadOS and macOS eventually. And the tech stack is Swift using SpriteKit and SwiftUI. So last time we were working on a cave, which is basically a path that your spaceship has to follow, and if you veer too far off the path, you die. So I was imagining it like it's you're flying through a cave, and if you hit a wall, you die. So we've switched this around a bit to be a bit more on theme for the space game, and we've turned it into a wormhole. So shout out to Nolan for that suggestion. And we've also got the actual art assets to work with. So yeah, it's always fun to have some nice art to work with while you're developing something. So shout out to Amanda for that. And yeah, so last time we were working on our cave, and the main issue we were encountering was performance. So it worked. You could fly through the cave, and it would detect when you veered off, and you would die. So that was good. But yeah, performance was not great. So we were dipping below 60 frames per second, which is always big no-no. And the reason was we were using a texture-based collider. So basically our path was this kind of white image, and then outside of this white path, it was transparent. And SpriteKit was using that to determine where the collider should be. So yeah, this didn't work very well. If you look at Apple's documentation, they basically just tell you not to use a texture-based collider, which makes you wonder why it's in the framework at all. But anyways, for our purposes, we're going to try a CG path instead. So basically this is a series of points that we use to make a shape, and then that shape is our collider. So you can think of it like a vector image, basically, SVG, something like that. So to start with, I've never used a CG path before for anything, really. So we need to figure out how that works. So I'm going to use a blank project, and the reason is whenever you're trying to figure out how something new works, it's nice to have this isolated place where you can try things without the whole rest of the project potentially causing some interference or confusion. So we start with a blank project, and we just start trying to construct CG paths and making a physics body with them in SpriteKit. So once we've got that working, we need to test performance, because if they don't perform well in our blank test app, they're definitely not going to perform well in our full main project. So what we do is just make nice for loop to spawn a whole bunch of these things and see how our frame rate does. So it performs well, so that's great, but now we have to figure out our next problem, which is why does it turn off?
It's only a game. Why you have to be mad?
So my light has stopped working, so I'm looking a little bit like a ghoul, but we're just going to roll with it. So where were we? Constructing a path. So we figured out how to make kind of a random path, but how do we make a path that actually matches our art? So my first idea was, what if we had an editor, kind of an editor mode in the game where you could load up an image and then use your finger, drag your collider shape you wanted, and then hit a button to save it, and then we could have that file that defines our colliders, and we can make each of our colliders that way. So the good part is that we're making our colliders directly on the image, so we know it's going to match. The bad part is that making that editor would take a lot of time. So after thinking about it some more, it didn't really seem worth it. So I decided on a different approach, which is having basically the image and then using SpriteKit's scene editor to drag a bunch of small circles where we wanted the control points, and then use those in code, go through them, and construct our CG path that way. So we get the benefit of an editor being that we don't have to guess and check point positions in code, which always takes forever. We get to visually lay them out, which is nice. But at the same time, it's right in code where we can access it, so we don't have to try to like make the shape in a drawing program and then figure out how to import it or something like that. So yeah, we can test out this approach in the blank app, and then with one image and one collider, and then if that works, we'll have everything we need to bring into the main project. So after some time, we got that working, so we're ready to bring it into our main project. So we bring in all of our sprites, our nice wormhole graphics, and we start laying out these control points. And one thing to note is we don't need any like fancy curves or exact matching, because this is just for collision. So it's fine to have kind of a crude series of points, because the player's not going to see them. They're just for our collision logic. So once we get all those control points laid out, we are ready to hook everything up. So we disable them from being shown. We use those paths to make physics bodies, and then we kill the player when they run into one of them, and we're all set. So at this point, I was a little bit frustrated to notice that we're still dipping below 60 frames per second. So I thought about this a bit, and I ended up realizing that we're still rendering our scrolling background, even though the wormhole art is completely covering it. So we're basically rendering two large images moving every frame for no reason, because you can't see the background. So in order to kind of avoid that unnecessary work, I made some changes so that the scrolling background, if it's behind the wormhole art, it's completely hidden. So we just hide it, and then once the wormhole section is done, we just unhide that background, and that helped our frame rate quite a bit. So now it's basically pinged to 60, and that means we're all done. Or are we? While testing, I noticed we were getting a phantom collision during the curved section. This didn't seem to correlate at all with the physics debug shapes you can see here in teal. Feel free to pause the video now if you want to try to think of why this was happening. If your guess was that the tail was colliding, you're wrong. It was actually because we're not allowed to have convex shapes in our polygon collider. So by splitting this into two separate shapes, we resolve the problem, and finally, we're done.